Greetings everyone. Today we're going to continue our discussion on how paper is recycled. Just kind of a reminder, the learning objectives of what we're doing right now is to just, first we identified what kind of contaminants come in recovered paper, and then after that we are going to talk about different contaminant removal methods, and then after that we will discuss how a total recycling system works. Last lecture we talked about screening, cleaning, washing, and flotation. In this lecture we're going to talk about kneading, bleaching, water clarification, and then we'll talk about how a total system works. Okay, just as a reminder, we start off with pulping. That's where we separate the fibers from the paper because we disrupt these hydrogen bonds. After that, we do operations such as cleaning that removes high-density contaminants, screening that removes large contaminants. Then we talked about two deinking stages. One is washing, where we literally wash away small ink particles that with water. And then the other one is flotation, where we use air bubbles to remove hydrophobic ink particles from the fibers. We're going to continue on now with what's called kneading. Okay, so kneading is a continuation of the pulping process. And in this process, what we do is we actually put the pulp at high consistency between these gears or teeth that actually move. So they're going to be, the teeth are going to move like this, and you can see a picture of that in the slide. And what happens is when those teeth move past one another, they have that high consistency pulp inside, and it rubs and breaks those ink particles. The other thing it does is it detaches the ink particles from the fibers. So we're making them smaller and we're detaching them from the fibers. Both things that we would like to see. The next process that we might do is bleaching. So if we're making a printing and writing grade, or if we're doing tissue sometimes, we like to have high brightness. For printing and writing, it's so that we can see better and write better. For tissue, it denotes some type of cleanliness to a customer. Most people think of whiter paper as cleaner, even though it may not always be the case. So bleaching is very similar to how we bleach kind of clothes. What we do is we use chemicals. The most common one is hydrogen peroxide, and we apply that to the pulp, and what happens is it attacks the dyes that are in, let's say, colored paper, and it can also attack the brown lignin that happens to be an unbleached paper making fiber, so the brown box. So we add the bleach, it attacks and chemically destroys those color forming bodies, and it reduces color and it gives us higher brightness. So we often do that in recycling. Okay, now another thing that we're doing in paper recycling operations is we're reusing the water quite a bit. So as you recall, we have to add a lot of water to our pulper in order to pulp the paper and liberate the fibers. And then we add water to cleaners and screens, obviously to washing and flotation. We add water to these to get to a low consistency solids level. And what happens is the water becomes dirty, and then we have to reuse it again and again. So what we do is we use clarifiers, and what clarifiers do is they remove suspended solids from water. So here we have what's called a dissolved air flotation clarifier, and let me see if I can show you how that works. So what we'll start off with is some dirty water. So that might have come from a washing deinking step. And then what will happen is that water will be pumped through some pipes. We will add chemicals. So these chemicals are used to flocculate the suspended solids. What does flocculate mean? Oh, okay. Let me try over again. All right, so I'll repeat this slide. So one of the things in paper recycling that we use a lot of is water. And we can't just use the water once and throw it away. We have to use it many, many times. In fact, we'll use water maybe 20 times before we actually discharge it. So the way that we can reuse it is by using a clarifier. And what the clarifier does is it removes suspended solids from the water. So it takes dirty water and it actually removes the suspended solids so that we have clarified water that we can be reused in the process. And it's a pretty interesting process. What we do is we start off with dirty water, okay, and that will have a high suspended solids, let's say 200 parts per million. And then what we do is we add chemicals. So these are positively charged polymers that are used to actually bridge suspended solid particles together. We call that flocculating. So we take those small particles, we bridge them together in flocculation, we make these big flocks. Those flocks actually settle or float better than the small individual particles. So then what happens is the dirty water and the chemicals come into what's called a clarifier. Now, before it goes into the clarifier, we add air bubbles to the dirty water. And what the air bubbles will do is they will attach to the suspended solids. And so we put air in here, the air bubbles come through here, they attach to the flocks, and what that will do is it'll actually float a lot of the suspended solids to the surface of the clarifier. Some of the other suspended solids actually settle down to the bottom of the clarifier and they come out as a settled sludge. So we have two actual reject streams, let's call them, the settled sludge and the floated sludge, and those are actually going to be pressed and then dewatered so that we can dispose of it. But what's our real product here is our clarified water. So we'll take our clarified water out here, and then that will go back to the process, maybe back to the pulper or back to a washing stage. But this is key and critical to the effective recycling of paper. Without this, we would be using too much water, it wouldn't be good environmentally, and it would be too cost prohibitive also. So this is a very critical part of any recycling operation. A lot of recycling operations that I go to that are having problems, it's because they don't clarify their water as effective as they should. Okay, so now I talked to you about the sludge that comes from the clarifiers. This slide right here talks about what kind of rejects we get for different recycling processes. So, for instance, if we are trying to make printing and writing grade recycled paper, and we're using graphic paper right here to, we're going to recover, okay, let me start over again. Okay, so this slide shows us how much waste is actually generated from different paper recycling processes. So if you take a look here, this first top row, we're going to take a recovered paper of news, magazines, and other printing and writing grades, and what we're going to do is we're going to recycle those into graphic paper, okay, so printing and writing paper. Another category might be we take office waste, and then we recycle that back into tissue. Okay, so there's my arrow indicating we're going from office paper to tissue. Another category is office paper to Deinked pulp, DIP, Deinked pulp, and then we can actually make take old boxes and recycle them into new boxes, and then finally we can take boxes and mixed waste paper and recycle them into things like shoe boxes and cereal boxes. Okay. Now, why am I identifying these different recycling systems? Well, because they have different amounts of waste. If you take a look, the amount of total waste is given in this column right here, and what you can see is for making recycled printing and writing paper, we lose about 20% of our material in reject streams. For making tissue, it's even higher, maybe 30-35%. If we make Deinked pulp that are sold to other customers that use it for making paper, we have to have very strict specifications, and that has a very high loss. When we talk about boxes, we don't have to remove inks, and we get very much higher yields. And so what this table does is it breaks up some of the sludges that we get. So like flotation de-inking, we have a sludge there, and then when we do whitewater clarification, which is basically the rejects that come from the washing, we get this amount of rejects. And then basically earlier in the process, we're getting heavyweight and coarse and lightweight and fine types of rejects. So these are coming from cleaners and screens and from contaminant removal in the pulper. Okay, so the bottom line here is that paper recycling operations, they do produce rejects. And those rejects are typically landfilled. Sometimes they're burnt, and sometimes they're actually applied to agricultural fields where we can grow corn, and the corn can be fed to chickens, and we can eat those chickens, really. So, and then sometimes they're put into construction materials, but for the most part, they're landfilled. And this is an area that's critical in paper recycling. If we can come up with new inventions and new technologies to better utilize these sludges, because there's a lot of good fiber in there, that would be very useful. Okay, so how do we measure how well we are doing in paper recycling? There's a bunch of indicators. Now, if you're at a paper recycling mill, you want to know about the production rate. How many tons of saleable product can you make per day? Because you have fixed costs. Those fixed costs are the cost to have the factory, the costs for lighting, the cost for employees. They don't change very much. So if you can make more sellable product, you can sell more money based on your fixed costs. Okay, yield is another one. Yield we define as 100% times how much usable product we make divided by how much recovered paper that comes in. Obviously, a paper recycling mill is going to want to have a very high yield. In other words, they want to save as much, they want to decrease as much input material for the amount of product they make. That's going to help their profits. The problem with yield is if you try to have too high a yield, your quality of your product goes down because there's some sacrifices you have to make to get high yield. You don't reject as much contaminants. Another thing that we talk about is parts per million of ink or dirt. And this ppm is defined as when we take a sheet of paper that we've recycled, we look at the total area of the paper and we calculate that. And then what we do is we use either manual methods or a computer method, and we count the area covered by dirt. And we take the fraction of area covered by dirt divided by the total area that we scanned or investigated, and that's usually a very, very small number, something like 0.00004 or something. And so because that's inconvenient to use, we multiply by 1,000,000 and we get a parts per million. To kind of give you an example, if we're going to recycle paper and we're going to make recycled copy paper, we want to get down to 10 parts per million. That's very, very small fraction of area covered by dirt. That might be one almost microscopic speck per 8.5 by 11 inch copy paper, to just kind of give you an example. A couple other things we look at if we're doing printing and writing, we want to know what the brightness of the paper is, how light that paper is. We actually measure it with the blue light, which is the scientific way of doing it, but really the brightness tells us how white that paper is. And then there's other pulp properties that are important. If we don't treat the fibers properly, then the fibers and the recycled paper have very low strength. Low strength is a problem for the final product, and it's also a problem when we try to run it on a paper machine. So now let's do a little exercise. What we're going to do is we're going to assume that we have a recycling mill and it takes in 500 tons per day of recovered paper. Now, we also know for that same recycling mill, we have 75% yield. So first, let's try and go ahead and calculate how much product we're going to make with this kind of scenario. So, let's just see here. So we've got our product, and that's going to equal 500 tons per day times, then we'll multiply that by the yield as a fraction. So what this yield is basically is for every 100 tons coming in, we're going to have 75 tons of product coming out. Okay, and that's going to equal 375 tons per day of our product. Okay, so that's interesting. Now let's figure out how much sludge we're going to produce. Now the assumption that is pretty good is that the sludge is going to be 50% solids and 50% water. Okay, so now let's calculate how much sludge we have. So here we go, sludge Oh. Now we're going to take that same 500 tons per day coming in, but if the yield is 75%, then the amount of sludge we're making is 25%. So we'll just multiply that by 25 divided by 100. Okay? And we know that the sludge is 50% water and 50% solids. So this calculation that we've done right here is basically the solids. So for every pound of solids or ton of solids we make, we're going to make actually 2 pounds of the wet sludge. So let's write that down. So we're going to say 2 tons of wet sludge per 1 ton of the solids. All right, so now that amount of sludge that we're going to produce is 250 tons of sludge. Okay. So these are very representative numbers for, let's say, a recycle mill that's going to make tissue. In tissue, we have to throw away a lot of the ink and contaminants and also some of the clays and fillers that actually come in with the paper to make soft tissue. But the point here is I want to emphasize that the amount of sludge that we make can be a huge number and can be a considerable fraction of the total output of the recycle mill. So why I like to bring this up is this sludge right here, typically, like I said, landfilled. If we can come up with some unique, innovative ways to make useful products out of this sludge, we can really improve the effectiveness of a recycle mill overall environmentally. Okay, so now let's just kind of talk about some recycling systems. I'm going to start off with a very simple one. When we make a box, in the process to make boxes, we clip a lot of pieces off. So if you look at that box in this slide right here, you see that we've clipped out handles, we've clipped out notches, we've clipped out places where the flaps can fold in. So when we're making boxes, we get a lot of clippings. So these clippings are very valuable. They're pretty clean too. And they're collected and baled up and they're sent to a recycle mill. Now, what we usually do with those is we make new boxes, correct? So because they're clean and they're homogeneous and they're pre-consumer waste, the recycling operation that we use to make those into new linerboard for the recycled boxes is very simple. So in this case, all we're doing is we're pulping up our clippings, just adding the water, breaking those hydrogen bonds. We're going to put it in a cleaner to maybe remove some stray staples or something from the sweepings on the floors that have gotten into the bales. And we're going to do a little bit of screening, again, really just to remove some gross contaminants that might have fallen in there by accident. And then we're done. So it's all it is disintegrate the fibers, remove some of the very basic contaminants, and then we're done. Because it's such a simple process and there's not a lot of contaminants there, what you can see is that our yield is going to be very high. It could even be 98% or higher. And for this process, parts per million, the amount of dirt or ink specks that are in there aren't that really that important because the brown fibers tend to cover that up. And brightness obviously is not as important as it would be for printing and writing grade. So nice simple process, very effective, takes clippings, makes new boxes out of it. Very effective. Now let's contrast that to taking mixed office waste, so mixed office waste, MOW, and recycling that into what we call away from home tissue. So I show a tissue, close-up picture of a tissue on the right. It actually came from McDonald's, and what you can see here is that there's it's not perfectly clean. So you see right here, there's a speck of ink, and you can just kind of go along and you can see all these little specks of ink. So we're going to try to remove some ink and brighten it up a bit, but it's not going to be perfectly clean. Okay, so for this process, because we do want to, we have some properties that we want to make this nice tissue, we're going to start off with a little bit more complicated process. We're going to start off with pulping, then we're going to do the cleaning, and at that point what I've written down here is that we've got parts per million of about 10,000. So that's going to be our ink content, and our brightness is about 67%. So we typically measure brightness from 0 to 100%, and 67% is where we're going to start. Okay, then we're going to do screening. That's going to remove some of the large contaminants. Then washing, de-inking to remove some of the ink. And you can see that our parts per million in ink is decreasing from 10,000 down to about 3,700. Then we're going to do the kneading. Remember what that was. That was that slow mechanical action where we're rubbing high consistency fiber and breaking those ink particles, making them smaller and detaching them from the fiber. And so when we do the kneading, we're actually breaking the ink down to subvisible sizes. So you can see we go from 3,700 to 900 ppm. Then after that, we do some bleaching to brighten it up a bit. And then we wash to wash out any of the inks that we had broken up in the kneading. And then our final properties, the parts per million is about 640, brightness is about 77%, and our yield for this process is going to be about 70%. Remember I mentioned that copy paper, recycled copy paper, has a ppm of 10 or 20 parts per million. That's necessary for printing and writing, but for this kind of lower quality tissue, we don't need to get to that cleanliness, so we go only to about 600 or 500 parts per million. Okay, now the next system I'm going to show you is relatively complex, and this is going to be to make de-inked pulp. So de-inked pulp, we usually call it DIP for de-inked pulp, is when a recycling company takes in, let's say, mixed office waste, and then what they do is they produce a very clean pulp that they sell to other paper manufacturers, and they buy that de-inked pulp. So when you have a customer, you have very strict specifications on ppm, brightness, even things like fiber content versus ash. Ash would be fillers like clay or calcium carbonate that is put into paper originally. So here for this process, take a look at what we've got. We're going to start off with a helical batch pulper. So basically what happens is we're going to put the paper in here and agitate it, and then after that's done, we're going to be removing things with the screens. So both of these two are screens here, and then we dump the pulp here, and then we dilute it with some water. We do cleaning to remove high density contaminants. Then another screen, it's a finer screen to remove large contaminants. Then we do flotation de-inking. Then the pulp comes down here to kneading. Then the pulp comes down here to do washing. So we're going to do washing and wash out some ink. Then we're going to do kneading to actually break up some particles and detach them from the ink fibers. Then after kneading, typically we do bleaching. And the reason why we do these together is because they have about the same solids content. So for kneading, we have to have high consistency. And for bleaching, it's also helpful to have high consistency or high solids or fiber to water ratio. Then after the bleaching, we add more water, we do flotation, we float out a lot of the ink, we do another washing stage, maybe even another bleaching stage. This one might be used to remove color and also to increase brightness. And then we're off. Then we make big pulp mats that we sell to other companies. And what you can see here is that we add water in various places, but then after the washing stage, when we wash away a lot of the solids, the inks and things, we have dirty water here, and those go to clarifiers, and the clarifiers regenerate relatively cleaner water which we can reuse many, many times. So again, this process is complicated, but it's complicated because there's lots of contaminants, and we have to get rid of all of them to meet the tough specifications that our customers require. Okay, now let's just kind of summarize. The first thing you should remember is that recycling uses a combination of many different operations to remove the different types of contaminants that come in. So we talked about screening, cleaning, washing, flotation, and then we talked about kneading to break some more contaminants down, and bleaching to brighten the fibers. And then you can't forget about water clarification. That's the way that we can reuse our water and effectively manage our water flows. Without that, we really couldn't have an effective recycling process. Now, the thing that we need to remember is that we're always producing a sludge. Sometimes it's a small amount, like 2% of our incoming material. But other times, like if we're making tissue or deinked pulp, it could be 30 or 40% on a solids basis what comes in. So we always need to understand that there is a sludge that's formed, and we really need good ideas in order to reutilize that and better utilize that in the future. Typically now we landfill it. In minor times we burn it or land apply it. And then I also want you to all remember that there's different recycling systems for different products. So the system that we develop, it depends on what we're taking in, what product we're going to make, and what are the specifications of the final product. Okay? And some of the things we think about is cleanliness. How we are running our operation, can it run smoothly, and we want to have as high yield as possible. Thank you for your attention. That concludes my talk.